Newton's first law, the law of inertia. Every object continues in a state of rest or of motion in a straight line at a constant speed, unless it is compelled to change that state of force exerted upon it. Newton's first law serves as an explanation for why the golf ball stays at rest until the player strikes the ball. Newton's second law, the law of acceleration. Every object, when acted upon by net force, will move with an acceleration dependent on the mass of the object. Acceleration equals net force divided by mass. While force is measured in newtons and mass is measured in kilograms, this is the explanation for why Tiger Woods and other professionals hit the ball further than the average player. Newton's third law, the law of action and reaction. Whenever one object exerts a force on a second object, the second object exerts an equal force on the opposite force of the first object. For the purpose of the explanation, let the first object be the golf club and let the second object be the golf ball. Newton's third law states that the force between the club and the ball during contact are equal. As the club hits the ball, it applies force to the ball, causing it to go into motion. The ball also applies an equal force back to the club. This force shows the club head down during the contact interval. Projectile motion is a form of motion in which an object or particle is thrown near the Earth's surface, and it moves along a curved path under the action of gravity. The only force of significance that acts on the object is gravity, which acts downward to cause a downward acceleration. The trajectory of a golf ball is affected by the club you use. Depending on the shot needed, different clubs are used. Some clubs result in a high trajectory with less distance, while some result in a low trajectory in more distance. Potential and kinetic energy. When you hold a golf ball high above the ground, it's full of energy, but it's all gravitational potential energy that is waiting to transform into kinetic energy as soon as you drop it. Why doesn't it ever bounce back to the original height? Because not all potential energy becomes kinetic. Some become sound energy, thermal energy, and elastic potential energy. Elastic potential energy is when the energy stored in a spring is due to its compression or stretch. Elastic potential energy is demonstrated when the ball is hit by the golf club and the ball compresses slightly before bouncing back into shape. Frictional forces. The friction force pulls down the club face on the surface of the ball, reducing the separation angle of the ball. Once you get into the 60-degree wedge type of club, the friction force cannot stop the ball slipping up the club face during contact. Once slipping occurs, the friction force reduces. Friction force acting on the ball from the club face produces backspin. The presence of the friction force also reduces the elevation angle of the trajectory, and all the other factors will be equal. Conservation of energy. Work is done on an object when you transfer energy to that object. An example of this would be when a golfer uses a club and gets a stationary ball moving when the golfer hits the ball. The club does work on the golf ball as it strikes the ball. The energy leaves the club and goes into the golf ball. This is a transfer of energy. We can say the club did the work on the ball.